Hello, welcome to Unit 10, Lesson 2 with Professor Blackman. Today we're going to be looking at different matrix operations. We're going to add or subtract some matrices, we're going to multiply some matrices, and then we're going to end by creating a system of equation for the matrix equations. All right, let's go ahead and get started on some examples. All right, so with these examples, what we need to do is create equations so that the matrix statements remain true. So what we have right here is a 5 and a y, and they're in the same row, same column in both matrices. So we can set them equal to each other. So y equals 5. We have x here and -3 here, so that is x equals -3. You can see that the -3 here and -3 here are the same. And then we can look at this 2z and this -8. So that's 2z equals -8. Divide both sides by 2, and z equals -4. So we get x is -3, y is 5, and z is -4. All right, let's look at the next one. So a plus 2 and -2. A plus 2 equals -2. B minus 8 and a 10. B minus 8 equals 10. C minus 4 and a 2. C minus 4 needs to equal 2. And D plus 4 needs to equal 4. D plus 4 equals 4. And now we just solve each one of those equations individually. A equals -4. Add 8. B equals 18. Add 4. C equals 6. Subtract 4. And D equals 0. So just make each spot equal the corresponding spot to make your matrix statements true. Let's look at some other examples. All right, so we are given four matrices here, A, B, C, and D. And in our first example, we're asked to find out what 2a is. Well, 2a is what we call scalar multiplication. So you have a 2 in front of your a. And with this, all you're going to do is multiply by 2, each term. So 1 becomes 2, 4 becomes 8, 2 becomes 4, and 3 becomes 6. Okay, we're going to do the same thing here with 3b. We're going to put the 3 in front of our b, copy down b, and then multiply that 3 into each term in our matrix. So that's -9, 6, 15, and a -3. And in our third example right here, we're going to add 2a and 3b together. Well, we already calculated what 2a and 3b are together. So now we just need to add them. So 2a is 2, 8, 4, and 6, plus 3b, which is -9, 6, 15, and -3. And when you're adding matrices or subtracting matrices, you add the same spot, so the same row and columns. So 2 and -9 become -7, 4 and 15 become 19, 8 and 6 become 14, and 6 and -3 become 3. So you just add each individual spot. So this 2 right here is row 1, column 1. This -9 is row 1, column 1. So we add those to get our -7. All right, let's look at some other examples. All right, in this one we are going to do subtraction. So I'm going to write out b as -3, 2, 5, -1, minus c, which is 1, -1, -1, 1. Okay? And it is the same as addition where we look at each individual spot. So -3 minus 1 is -4. So that top left in each. Now we're going to do the top right in each, which is row 1, column 2. 5 minus a -1. So that's 5 plus 1, which gives us 6. 2 minus a -1. So 2 plus 1 gives us 3. And -1 minus 1. So this is -2. And that's what subtraction looks like with matrices. All right, now we are going to do multiplication. So we're going to start out by doing A, B. So I'm going to copy down A, 1, 2, 4, 3. And B as -3, 5, 2, -1. Now, multiplying matrices is a little bit more challenging than addition and subtraction. So I'm going to use a lot of color to show what I'm doing. So we're first going to look at row 1 and column 1. So you multiply the row of the first matrix by the column of the second matrix. And so what that looks like is 1 times -3 plus 2 times 2. So you're multiplying each term in the row by each term in the column individually. 1 times -3 and 2 times 2. All right. Then we look at row 1 with column 2, and that will go in row 1, column 2. So that is 1 times 5 plus 2 times -1. All right. And now we're going to look at row 2, column 1. And so that's 4 times -3 plus 3 times 2. Then we're going to look at row 2, column 2, which will go in row 2, column 2 in our AB matrix. So 4 times 5 plus 3 times -1. And then once we have written all of that out, then we just need to simplify. And we will get our 2 by 2 matrix. -3 and 4 gives us 1. 5 and -2 gives us 3. -12 and 6 give us -6. And 20 and a -3 give us 17. And that is how we multiply matrices. You do the row of the first one by the column of the second one. All right, so now we're going to do BA. So BA, -3, 5, 2, and -1 is B. And A is 1, 2, 4, 3. Now, with a lot of multiplication, yeah, 3 times 2 is the same as 2 times 3, but that's different with a lot of matrices, and that's why I want to show this example as well. All right. Start by drawing my matrix box. All right. So row 1 by column 1. So we have -3 times 1 plus 5 times 4. Okay, and then we do row 1 by column 2. And so that's -3 times 2 plus 5 times 3. Row 2 by column 1 gives you 2 times 1 plus a -1 times 4. And then row 2, column 2 would give you 2 times 2 plus a -1 times 3. And then we have to simplify that. And so that would give us the 2 by 2 matrix, -3 and 20 give us 17. -6 and 15 give us 9. 2 and -4 give us a -2. And 4 and a -3 give us 1. So as you see, we end up with completely different matrices when you have AB and BA. If I want you to look at what's going on, if you notice inside the parentheses, right here and here, it's the same numbers. That is just something that occurs when we are doing our matrices. And then if you look here and here, you get these same numbers, same thing as here and here. And so that's just a pattern that you'll see. Here you have the same 5s, the same -3s, and that's just a pattern that you see as you are working through your matrices. All right, let's look at another example. Okay, we're going to do DC and CD. So start by putting D, and then we put C. I'm going to go ahead and write CD as well. All right, and then let's start multiplying. Row 1, column 1 gives us 1 times 1 plus 1 times -1. Right? Now we have row 1, column 2. So that is 1 times -1 plus 1 times 1. Row 2, column 1 gives us 1 times 1 plus 1 times -1. And row 2, column 2 gives us 1 times -1 plus 1 times 1. And now when we simplify that, that's 1 and -1, which gives us 0. -1 and 1, which gives us 0. 1 and -1, which gives us 0. And -1, 1, which gives us 0. All right, now let's do that with CD. I know it will be a 2 by 2 matrix when we are finished. So 1 times 1 and -1 times 1. 1 times 1 and -1 times 1. negative 1 times 1 plus 1 times 1 and negative 1 times 1 plus 1 times 1. And when we simplify that, you notice that 1 and negative 1 give you 0, 1 and negative 1 give you 0, negative 1 and 1 give you 0, and negative 1 and 1 give you 0. So in this case, these two do actually end up equaling each other. All right, so do another example. All right, the directions say find the product if possible. So that means there's a case that it may not be possible. So what we want to do is look at the row and columns of the first one, which this is a 2 by 3. And in the second matrix, this is a 3 by 1. So if these agree, then you're good. The ending result will be a 2 by 1 matrix. Now, if you look at our second one, this is a 3 by 1. And if you look at the second matrix, it is a 2 by 3. And since these do not agree, we cannot multiply. Which is great because then you're done with that problem pretty quickly. All right, so let's do problem 1. So we need to create our 2 by 1 matrix, 2 rows, 1 column. So negative 1, negative 1 times 3, uh, 0 times negative 4, plus 5 times 1. And then we do row 2, column 1, and that will be in row 2, column 1. So 3 times 3 plus negative 5 times negative 4 plus 2 times 1. So if you look inside those parentheses, we have the 3s, the negative 4s, and the 1s because we're multiplying by the same column. And then we need to simplify that. So it will be a 2 by 1 matrix. Negative 3, 0. I'm always happy to see a 0. So negative 3 and 5 give us 2. 9 and 20 be 29. And 2 give us 31. And there is our product. All right, let's look at our last examples. All right, here we need to create a matrix equation. So what we're going to do is this is x and y. So we have this matrix x and y, and that will equal these 7 and negative 6 over here. And over here, we create a matrix with all the coefficients. 2, negative 3, 1, and 5. So if we multiply this, 2 and negative 3, by this, so that gives you 2x negative 3y, that would equal the 7 that's here. All right, so let's do the same thing with our second example. So we're going to start by creating the x, y, z matrix, and that will equal the 6, 7, and 8. And then with all the coefficients, we fill that in as 1, 1, negative 2, 3, -1, 1, 2, 5, -3. And that's how you create a matrix equation with the AX equals B format. This is different from the augmented matrix that we created in Unit 10, Lesson 1. All right, that's all I have for you today. Happy studying.